Hi guys, today we are going to speak about applied mathematics for Bocconi and we are going to concentrate ourselves on the financial calculus. The best way to start is speaking about the two types of processes that we have in financial calculus. The first type are the so-called accumulation processes, which would be this process that you can see here. The one for which we know, so I'm going to mark it here with the accumulation process. And so the accumulation process is the one in which the main question is, if I invest today the principal P, so a certain amount of money today, how much money am I going to have in T years, so in timeline? So the unknown is A. A is the so-called accumulated amount, also known as the final value. On the other hand, the opposite process to the process of accumulation is the so-called discount process. Now, inside the discount process, what we know is n. N is the so-called nominal value. And the main question is, how much is this amount of money worth today? So the unknown thing is called P, which stands for present value. So to sum it up, accumulation processes tend to bring you from zero to a future date T, while the discount processes tend to bring the amount of money that you have at the future date T, and they tend to bring it to zero to see how much that amount of money is worth today. So a simple example of the accumulation process would be the one in which I'm putting today 100 euros and I'm asking myself, how much is this money worth in T years, in 5 years, for example? That would be an example of the accumulation process. While in case of the discount process, I know that in T years I'm getting 120 euros, and the question is, how much is that money worth today? That would be the basic difference between the two types of processes. Obviously, as you can imagine, let's concentrate a little bit on the accumulation processes. What we can imagine here is that, what are you expecting? That in this accumulation process you are earning money. So I'm expecting that A is bigger than or equal to P. That is the main conclusion here. I also expect the same thing for between P and N. I'm also expecting that N is going to be bigger than or equal to P in the discount process. Those are logical conclusions based on the stuff that I have just told you about. Now, there are two possible ways to define each of these processes, and we're going to mention them. So let's concentrate for a second on the accumulation processes. Inside the accumulation process, we are going to speak very briefly about the additive approach and the multiplicative approach. The additive approach is telling us the following thing. It's telling us that the final amount of money, A, that you have at the end of the accumulation process, so this amount here, right, is equal to the principal that you invested plus the amount of interest I that you earned in the meantime. So I is the amount of money that you earned by putting the money at zero, investing your principal, and then waiting 40 years in order to get this money back plus the interest on top of it. So what am I expecting based on the stuff that I've just told you? That the amount of interest I earn is bigger than or equal to zero. That is an obvious conclusion. Let's go to the second type of approach that you will see very soon is more important than the first one, and you will see for which reason. It is called multiplicative approach. Now, the multiplicative approach says the following thing. Instead of saying that A is equal to P plus the amount of interest that you earn in the process, we say that A is equal to P times F. And F is the so-called accumulation factor. So F is telling you how much money are you going to earn when you go from zero to a future date T. And the factor F is telling you actually by how much is your principal going to increase in the meantime while you are waiting for your investment to come back. Based on this, what am I expecting? That F is bigger than or equal to 1. That would be the logical conclusion. So for example, if I invest today 100 euros at zero and I get in a year 120 euros, what was my accumulation factor in this case? It was 1.2 because 100 times 1.2 equals 120. So that's what the accumulation factor is, and it corresponds to the so-called multiplicative approach. Those would be the two approaches in case of the accumulation process. remember that the name of the of F is accumulation factor. So that's what is important here. It is accumulation factor. Now, going further, what we know going further is we need to speak about also the corresponding approaches for the discount process. So if I stop for a second and if I speak about the discount process, what we are going to have is the following thing. Again, we have the additive approach, and the additive approach is saying the following thing. Additive approach. So additive approach is saying this. The present value of money that I have today is equal to the nominal value minus the amount of discount. So you will remember that in case of the discount process, we said that you are bringing a future amount of money n called nominal value, and you're trying to bring it to 0 and see how much is it worth. So p would be the present value. So if I know n, to get to p, I need to subtract something from n to get there. So for example, if I know that in 2 years I'm getting 150 euros, the question is, how much is that amount of money worth today? And the answer is quite simple. I just need to subtract a certain amount of money that we call discount. So it's an amount of money in euros, obviously, in order to see how much is this worth today. In an example, D could be worth, for example, 40. If D is worth 40, we're going to have that P is equal to 150 minus 40, so it's equal to 110. So 150 euros in 2 years are worth 110 euros today, provided that the discount that you can apply here is equal to 40 euros. Good. If we move on and we speak about the multiplicative approach, now in case of multiplicative approach for the discount process, it's again quite simple. So I have the P, the present value that I need to find here, is equal to the nominal value times the so-called phi. Phi is called the discount factor, and it's as important as the accumulation factor is important. So this is called discount factor. Now, what is, I would say, logical in this case here is that if n is bigger than p, and we know that n is bigger than p, then phi must be smaller than or equal to 1. Why? Because let's say that n is equal to 150. I need to multiply n by a number smaller than 1, that is to be precise, by a number between 0 and 1, in order to have a present value that is smaller, that is 110, as in this example that we had here. So that's how multiplicative approach works. So the discount factor then is telling you how much do you need to, let's say, subtract from the nominal value to arrive to the present value. Those would be the two factors that we are going to speak a lot about in the future. I would like to mention here one more thing, and that thing are called conjugate vectors. Now, it's a definition that makes a connection between the accumulation factor and the discount factor. So let's speak about this. In the accumulation process, we said that A is equal to P times F, and I'm going to call my accumulation factor F of T, meaning what? It's a function of time, which was also obvious from the timelines that we drew in the beginning. Okay, that's what I can say about this. What about the corresponding discount process? I'm going to have that the present value is equal to the nominal value times phi of t, so times the corresponding discount factor. Now let's make a very simple timeline and a very simple graph. So we have today's time, 0, and we have future date t. At 0, you can invest principal to get a future amount of money, A, that we called final value. A can also be marked with big letter M, but let's say it's A is more common. That's the accumulation process. The corresponding discount process says you know how much money you are going to earn in the future, so it's n nominal value. And then the question is how much that amount of money is worth today. So the arrow is facing backwards. And the money that I got today is called present value. If I'm speaking about the same amounts of money in the accumulation and a discount process, obviously I'm speaking about two same processes. The only difference is the point of view, because in the accumulation process I know P and I'm going forwards to find A. In the discount process I know N and I'm going backwards to find P. If we are speaking about the same amounts of money, then it just means that the point of view is different between the accumulation and the discount process. For example, I know that today I'm investing 100 euros to have 150 tomorrow. That would be the accumulation process. And I can find 150 using that logic. So multiplying 100 by the corresponding accumulation factor. Or I can know, for example, that 150 euros worth in 3 years are worth 100 euros today. How? I take the 150 euros and I bring them to 0. Using what? Multiplying 150 times the corresponding discount factor, which is, as we said, smaller than or equal to 1, as we saw here. Okay, now if everything is the same and the only thing that's different is the point of view, what I can then say is that n is the same as a, right? So let's use this conclusion and let's come to another important conclusion, which says this. If I know that the present value is equal to n times phi of t, and then if I said that n is the same thing as a in the same process, the only thing the difference is the point of view, then instead of n I can write a. So follows p is equal to a times phi of t. And for a, what do we know? That a is equal to p times f of t, the formula we said at the beginning. So let's plug it in. So we have that this is equal to p times f of t times phi of t. So what do we get? We got that p is equal to p times f of t times phi of t. Using simple mathematical rules, I can cut the two p's, and as a consequence, we arrive to this. 1 is equal to f of t times phi of t. From there, we can make two conclusions. That f of t is equal to 1 over phi of t, or that phi of t is equal to 1 over f of t. So this means that the discount factor and the accumulation factor are just the reciprocal value of each other, and hence they are called conjugate factors. So to conclude our definition, f of t and phi of t are conjugate factors. And this is what the definition actually means. So this is the definition, and it just means that each one is the reciprocal value of the other. If you know one formula, then you obviously know the other also. So this would be the conclusion. Next time, based on the things and the stuff that we have done today, we are going to do one variable financial laws. The most important one variable financial laws, which are simple interest, compound interest, and anticipated simple interest, and obviously their counterparts, which would be simple discount, compound discount, and bank discount. So thank you for listening to me, and I'm looking forward to having another lesson with you very soon. Thanks.